When I was in college, I was not going to be a teacher. That was not on my list of things to do. But I was going to be a medical technologist, and then in third year college, I had to be in microbiology classes, and I'd look at those bacteria in the microscope and I think they kind of all look alike to me. I probably shouldn't go into this because whatever I say, the doctor will, whatever I say the bacteria or virus or whatever is, the doctor will give a medicine based on that. I thought, somebody needs to be more decisive that goes into this career. So by that time I had done tutoring of college algebra and physics and chemistry, and I thought, maybe I'll be a teacher. I'll do that for a while. Well, I'll do that for 5 years and get it out of my system. Well, that was 1978. I still haven't gotten it out of my system. I just love helping kids and helping people learn. And I taught for a number of years, then I did my stay at home, be a mom, but that also means you don't really stay at home. You do volunteer work or whatever. So I helped at my kids' schools, and I did lots of math and was a band parent and stuff. And that was fun. I just loved it. And I did that for all the 18 years that they were going through, and then I just kept on going some more. And finally I thought I should just stop. So after 27 years of volunteering, I thought, okay, I'll stop. And I'm not quite an accountant. I haven't, when I was 60, I decided back it up. I had gone back to teaching when our first kid hit college. And then I thought, okay, I'll teach for a while. It's fun again, but it was a lot of work, and but I didn't mind that. And so that was good. At some point I thought, I need to just quit and stop doing all this and just start doing something else. And so I got hired at an accounting place, and they taught me how to do bookkeeping and everything, and I learned how to do taxes, and I thought, well, this is interesting. So at age 60, I went to Pikes Peak Community College and started an accounting degree, and I thought, this is cool. Somebody should have told me about this 40 years ago. But oh well, life's got twists and turns. Once I was just working part-time, then I had time to tutor. Couldn't get it out of my system. So I started tutoring, and then I came up with all of the stuff for a math website. My son, by that time, was done with college, and he goes, I could do it, Mom. I could make your website for you. Okay, go ahead, do that. And so anyhow, that's what we came up with. It's free. I meant it to be free, always to be free. We'll see. Like Khan Academy is meant to always be free to use, and that's good. But Khan Academy has also gotten millions and millions and millions and millions of dollars to help them make Khan Academy what it is nowadays. I don't get millions of dollars. So it is meant to be supplementary. It's meant to help. It's meant to help people. It's not meant to be your math curriculum. You got big, powerful curriculums out there. There's no way I can compete with all of those, but that's okay. And then somebody suggested, why don't you turn some of this into an app? So I did that. I found somebody, math and computer teacher at Coronado High School. And so during the summers, he would make more and more of my work into apps. And so I got 8 of those, and then I've gotten 6 of those converted to being available on Android devices so that I can reach more people around the world. So they've been downloaded over 150,000 times in 96 countries, which surprised me. I just thought it'd go gangbusters in the United States. I didn't know it'd go around the world. Like the latest 2 countries were Bolivia and Azerbaijan, and that is somewhere over like east of Greece and Turkey, if you have an idea there. But it's been fun. It's been downloaded on 6 continents and stuff. So cool, and they're all free also. Somebody had said, make one of yours cost money, Marianne, you can make some money sometimes. Oh, okay, so I made one be $1.99. No one downloaded it. Some of the other ones would be like 2,000 downloads in a month. No one downloaded it when it was $1.99. So I asked the computer person, can you just make it free again? I mean, this is pointless. He goes, sure. So anyhow, now they're all free. And it is what it is. So I would like to, at some point I became working with Parent Challenge. And so that's what came about as me doing math presentations. When I do it for high school, I would love to have you be very, very solid in your algebra ability. And it's very prevalent nowadays that algebra is built right into geometry and geometry is built into algebra. And that's okay. It is what it is. It should make you stronger in your algebra if you're in geometry and you end up going, there's algebra in my geometry. Yep, that's okay. Should make you stronger. If you look at the SAT questions and ACT questions, a lot of them are algebra and geometry. So, so when you're getting stronger in algebra and geometry, it's helping you on your future SAT, PSAT, ACT kind of scores. So that's my thinking that way. At some point, if we need to, I'll start doing advanced algebra. But for right now, strengthen your algebra and your geometry. Okay, in your handouts, that first little half page is your agenda. Well, I tried to streamline it. The first thing I put on there is the hierarchy of thinking skills, which is your next half page. And these are Bloom's taxonomy of cognitive domain. In other words, higher levels of thinking skills. As you go up those words, they get harder. And knowledge is the biggest, broadest one. Like when you're in kindergarten and they taught you all the uppercase and lowercase letters of the alphabet. That's building your knowledge. And then comprehension, like when they taught you to kind of sound it out, that's comprehension. When you were learning math way back then, it was like 4 plus 3, and you would do visuals, and you would have to draw squares or whatever. Comprehending, do you know what it means? And then application, can you apply that again when it's not just 4 plus 5, but what if it's 34 plus 25? So application, and then analysis, synthesis, and evaluation. The very top one, sometimes they have you, in some of the textbooks, it'll say, evaluate this, what went wrong? Find the missing step, find the step that went wrong, or something like that. That's great because it's the highest level of that Bloom's taxonomy, and it's making you have to analyze. It's making you have to know, what am I looking for? What am I looking at? And then evaluate it and come up with what is the right answer. Okay, synthesis, we usually don't do so much in math. That would definitely be in English, where you have to write papers. Or when you were younger, you had to write book reports. You had to come up with something that was yours personally. Evaluating sometimes, like I know my kids, when they went through high school and the day that their rough drafts of their papers were due, the English teacher would put them in groups of 4, and each kid would have to read theirs out loud, and they had to have a copy for each person. And everybody would evaluate each other's. They had to know what to look for. They had to know, so knowledge. They had to be able to comprehend, okay, is that a good starter sentence? Is there support for that sentence? They had to analyze. Okay, so you do it in all kinds of subjects. But tonight, obviously, my emphasis is going to be on math. Okay, when your teachers are pushing you through topics, they're wanting to make you more solid and getting you to using your higher, tougher skills. Let them teach you. Don't resist it. Okay, let them teach you. Be a good learner and listen and do what you need to do. Analyze, watch what they're doing. When my kids would get busy, like in cross country or whatever, that just ended up making them be very good at trying to get the most they could out of what the teacher was saying, because they probably wouldn't have time to do homework tonight. They survived just fine. Okay, you'll need to be willing to learn these and then apply it and do it again and again and again. Okay, so I'm just trying to let you know, hang in there, work hard, it'll all pay off for you. Then math review, not sure we're going to need all of this, but math review, it's just taking you through geometry topics, page 1, 2, 3, and 4. So we're going to blast through these because I think they're not brand new to you. Okay, on that first part, you've got two parallel lines cut by a transversal, it's called. Okay, this one's 1, 3, 5, 6, 8, 4, 2, 7. It just so happens that when you have parallel lines cut by a transversal, 4 of the angles are going to be congruent and the other 4 are going to be congruent. So as soon as you know one of them, you know all of them. Okay, these two make 180. So if I know this is 60, this would be 180 minus 60. All of the obtuse ones will be exactly alike and all of the acute ones will be exactly alike. So on A it says the measure of angle 1 is 44 degrees. Okay, and then it says find the measure of angle 2. Okay, if that one's 44, that means all of the acute angles are 44. And then it means, so then this acute angle is 44. These two would make 180. So 180 minus 44. 180, take away 40. And then take away 4, what do you have left? 180 minus the 40, and then take away 4. What do you have left? Pardon? 136. Yes. Very good, Mom. 136. Okay, the next one, angle 6 is 112. So it's a different picture. 112. Okay, 112, and they want to know what's the angle 2. So angle 12, angle 2 is right here. Is it obtuse? No. Is angle 2 obtuse? Is it big?
Or yeah.
Yeah. So all of the obtuse ones are going to be 112. So the answer is angle 2 is 112. Next one, angle 5 is right here. And they say that's 144 degrees. And again, you're supposed to know angle 2. Okay. Is this one obtuse?
Yes.
Is this one obtuse? Yep. And they're called vertical angles whenever you have 2 lines crossing. 2 are congruent, 2 are congruent, where they're all 4 congruent if it's a right angle. Okay. So angle 2 again is 144, same as this one. That is the weirdest thing to call these vertical angles. What's vertical about them? But I can't change the name. It's just the weirdest little thing. Okay, next one, it says supplementary angles. Here's where you got some algebra going on. Okay, what do you know about the grand total number of degrees?
Did you say supplementary angles?
Yes, they're supplementary angles. What do you know about the grand total degrees for supplementary angles that form a line like that? 180, yep. And so you know that 3x and 6x together make 180. So 3x and 6x, 6x and 3x like $6 and $3, it is $9. So $9 or 9x equals 180. 9 times what makes 18, and then you put the 0 on. Yep, x is 20. So then this angle would be 3 times 20, which is 60. Yep, and then this one would be 6 times 20, which is 6 times 20, which is 120. And is it true that the 120 and the 60 makes the 180? Yeah. Yep. Good. Then, oh, the next one just got harder, but that's okay. Okay. Woo. 3x plus 3, and this is 16x plus 6. What do you know about their total? 180. So can we already add to put them into the equation? What's 3x and 16x, just like $3 and $16? Yep, $19, so 19x plus 3 plus 6, so that'd be plus 9 equals 180. How do I get rid of adding 9? Yes. Do the opposite. So you got 19x equals 171. Then you might not know your multiples of 19, but 9 times what will give you a 1 in the ones column? Well, it's 81, so 9 times 9, and that is what it is. 19 times 9 will give you that. I was born before calculators, so I had to come up with fast ways of having to do this. And to me, it's like work smarter, not harder.
Okay, but how did you do that again? Because even
Okay.
how you did that quickly.
Okay. 19x plus, equals 171. If it goes in there evenly,
Right.
9 times something has to make a 1. Well, I know that 9 times 9 will make a 1 there because it'll make 81. And that does end up being what it is. And if this was a classroom, everybody would be punching it through their calculator.
Oh, so you were just trying to figure out if it got into 81.
Oh, figure it out. Good for you. That's the title of today. Perfect. Okay. Woo. Okay. So on the next one, you got 6x minus 12, 6x minus 12, and 11x minus 12. So when we make the equation, let's already combine your x's, because again, it's going to make 180. So 6x and 11x would make, okay, 17x minus, got minus 12 and minus 12, so minus, okay. The nice thing about this is to get rid of subtraction, you do the opposite, so you get to, yeah. Okay, 17x equals 4 and 0, 18 and 2. Okay, now, this has a 7 in the ones column. If I want to get a 4, I could multiply by 2, because that'll give me 14, but that won't get us there. How about if I do times 6, because that'll give us 42. And if you work it out, it is 6. Do you see how I did that? There's only 2 ways to, oh, man. I got a 4 and then I got a 2. That didn't make much sense at all. Okay. That didn't make much sense. Whoops.
X is not 6?
17, it's not 6, no.
Oh.
Whoops. 2, oh, 4. I need a 4. 7 times 6 would make a 42. And why I thought for a second there that I was going to be okay, I don't know. This is why I'm not a surgeon. I can't go, oh, whoops. This is why I'm not a dentist. Oh, sorry. You can't do that when you're a dentist. Okay. So it ends up being 12. Okay, in case your calculator battery goes dead or something, you've got to have it a strategy. Okay. Number 3, these are complementary angles. Complementaries, okay. C comes before S, 90 comes before 180. Complementaries add up to 90, supplementaries add up to 180. So for 3A, those two add up to 90. X plus 36 adds up to 90. Wow. Okay, all right. Oh. That's not a whole lot better. So you would set X plus 36 equals 90, and you'd work that out. For B, you would say 9X plus 1 plus 44. Got 44, 9X plus 1. These two together make 90 degrees. So 9X, then you got a 1 and a 44, those can make 45, equals 90. How do you undo adding 45? Yeah, subtract 45, and you get 45.
54. No, it has to be 46.
9 times what makes 45?
5.
Yeah, so X is 5. If X is 5, what's 9 times 5? 45 plus 1 is 46. And sure enough, these two do add up to 90. Okay, one nice thing about geometry when they throw in algebra, hardly ever is there negative numbers. Round of applause, huh? There's way too much emphasis on negative numbers in algebra as far as I'm concerned. Unfortunately, you have to go through the pain and misery of it, but you'll survive. Okay, next one, you got a 90-degree angle, split into 2 parts, 8X plus 7, and a 2X plus 3. Okay, so if we're going to make our equation, how many X's and how about the number? Okay, 10X plus 10 equals 90. What plus 10 makes 90? 80. So this has to be 80. So 10 times what will be 80? 8. You're so smart. There you go.
Just the parent answering it.
Oh, no, I'm still on the first one trying to figure it out. Oh, my God.
Okay. Number 4. This is one of those hierarchy skills where you analyze. Analysis is one of your levels. Are these pairs of polygons similar? Well, to be similar, the corresponding angles have to be exactly alike, and the corresponding sides have to be in proportion, which means, okay, 12, 12, 10, and this one is 8, 8, 8. So if I put this one over this one, would I get 8 over 12, and would I get 8 over 10?
No.
No. So no, they are not in proportion. Okay, keep on analyzing. The next one, a right triangle where it's 9 and 9 for the 2 sides, legs, and then a smaller one where it's 4.5 and 4.5.
Yeah.
Yes, good. How about C? One looks like a parallelogram and one looks like something else.
Well, it looks like yes, but I mean, who knows?
Not quite, but not quite enough, huh? Yeah. Okay, good analysis.
Angles or numbers?
Pardon me?
That would be acceptable?
Say it again, what?
You can do that without any angles or numbers for C? That would be
Correct,
acceptable?
because you can see that this line slants down, this one is vertical. They can exist, they just don't get to be called similar. Okay, find the area of circles. This doesn't have much to do with algebra as far as like making an equation or anything. But just to slide through the thinking, circumference of a circle is what? Area of a circle. What are the formulas?
Pi r squared.
Okay, which one's pi r squared? Okay, it's good to figure it out. Okay, if you were gonna, here's a rectangle, if you're gonna walk around the outside, that's just gonna be the distance, that's the perimeter, right?
Right.
And that is just meters or feet or whatever, okay? If you're gonna talk about there's 4 this way and 2 that way, then if you're gonna talk about the area, there's 8 what? Square units. So square units is always with area, and single units, if you want to call it that, are always just like circumference, just means the distance around a circle. So it's a perimeter, but it's got a special name. Okay, so this is pi times diameter, or a diameter is 2 radiuses, so it's 2 pi r. Area is pi r squared. Square units will be for area. So if you can't remember which should I use, if you're looking for an area, you want this one. Does that make sense? Good. Okay. Surface area of a cube. Will you need to know this in life much? No, but it's not that hard to figure out. Okay. Cube. Got to give sound effects. Okay. If every side is 9, well, what's the area of this side? 81. How many sides are there on a cube? Top and bottom, and then going around the side. How many are there? I know, it sounds simple, but makes you think. But that's okay, making you think.
Thank goodness you brought those.
If all else fails, count them up by hand. So how many sides are there? Well, there's
6.
top and bottom, and then there's 4 around the side. So if every side is 81, the question is, what would be the arrow? I guess I'm doing B. What would be the area of the whole surface area? Well, there's 6 of them. 81 times 6 would be, pardon? Okay. Oh, times 9? Whoops. No, because there's 6. Man, I'm getting confused. I should have had dinner. No, just kidding. Can't blame it on that.
So you found the area, and then you multiplied it by all the sides.
Yes.
Okay.
Yes. Okay. What if we do the first problem where each side is 6, what's the area of one side? 36. And then how many are there? Times 6. Yep. That makes sense? Okay. 20. What if it's 20 feet on the side?
So 20 times 3?
20 times 2.
So if there's 20 this way and 20 this way, each side is,
So that's 60 times 6?
so on this side, it'd be how much?
2,400.
Yeah. Okay. 2 times 2, which is 4, and a 0 from each of the 20, so 400 square units. And then there's 6 sides, so the grand total is? Okay. Going on to number 7, find the area of triangles. And then using Pythagorean theorem, you can bet both of those will be somehow on a SAT or ACT test. Absolutely. It'll probably be only a part of a problem because they'll want you to put things together and it'll be a multi-step problem. But then you need to know the steps. Okay, find the area of a triangle. Okay. What's the area? How do you find the area of a rectangle? Yep, base times height. Every parallelogram could have this chopped off and brought over here and become a rectangle. Therefore, every parallelogram has the same formula as a rectangle. Every triangle, oops. Every triangle is a half of a parallelogram. Therefore, every triangle is 1/2. Yes, 1/2. Base times height. Yep. Then if it tells you, here's the base, here's the height, on that first one, 1/2 base times height, I was a stickler for you had to write down the formula first. Equals 1/2 times, they say the base is 70 and the height is 90. Half of 90, what? Okay, what's 7 times 9?
63.
Yep, 63. Then you put on the 2 zeros. Now I could cut it in half. What's half of 6,000? 3,000. What's half of 30? 15, and then I still have a 0. That make sense? Okay, and that'd be square meters. Yes, you can say meters squared, but I think this gives our brain a more of a picture, square units. Okay, next one, that's throwing in decimals. Okay, so again, base is 6. 1/2 times 6 times 5.16. Ooh, okay, area equals. This is where I would work smarter, not harder. What's half of 6? 3. So all of this becomes 3. What's 3 times 6?
18.
18 with a 1. 3 times 1 plus 1? 4. And then 3 times 5. 15, 2 places, 2 places. Then you can kind of spot check yourself. 3 times 5, yeah, that'd be reasonably 15 point something. Okay. The next one, I don't think we need to do, you'd take half of 20 and take that times 44. Or do you want to do that one?
Yep, let's do it together. I need to learn.
Okay. So area equals 1/2 base times height. The base is 20, and the height is 44. What's half of 20 is? 10. So you just made your life easier. This is 10. 10 times 44 would be 44 with a 0, so 444 square meters. Okay, that makes sense? Okay, Pythagorean theorem, you can bet that'll be on, somehow you'll need to be able to use that. What is the Pythagorean theorem? C squared equals.
A squared plus B squared
Mhm.
equals C squared.
Pythagoras didn't have much to do after he was done feeding the camels or whatever, so he scratched around in the sand and went, oh, look at that. So no, I don't know. That's my story. I don't know that it's true. So C squared equals A squared plus B squared. A and B are the two sides that make the right angle. Would it matter if you call this one B and that one A? No. Okay. The one across from it, one across from the right angle, is automatically C. What is that side that's across from it called? Starts with H.
Hypotenuse?
Yeah, hypotenuse. Yep. Okay.
That's my contribution for the evening, y'all.
Okay. And for some silly reason, these are called legs. Now, hypotenuse sounds like a Greek word or something, and A and B are legs. Who came up with these? I don't know. Okay. So then your first one has 60 and 80. And you're supposed to find the missing side, which is C. So C squared equals A squared plus B squared. So C squared equals 60 squared plus 80 squared. C squared equals.
480 squared.
Which one?
You have to do 6 times 6 and then put 2 zeros on. 8 times 8 and put 2 zeros on.
Oh, 4,800.
plus
Right.
Okay.
3,600 plus
And then,
6,400.
okay. And then, so C squared equals,
But 8 times 6 is 28.
No, the square, you're getting the square.
10,000. So C is the square root of 10,000. Anybody know the square root of 10,000? You actually do.
yes.
10.
100.
100!
Yay! That's
Guessing-
my second contribution.
guessing
Y'all,
is
I was
allowed.
happy that-
It's 100 with a 0 free.
You are
2
so
zeros,
sweet
yep.
in my brain.
Okay.
Right.
Okay.
I think that this should be only
So 60, 80, 100.
It's only one answer.
Now, without erasing these, and you'll see why, if you have a 30, 40 right triangle, so C squared equals 30 squared plus 40 squared. C squared equals 30 squared would be,
That one, so it's gotta be C.
That means 900, right?
okay, 900. 40 squared will be,
1,000.
okay, 1,600 because it's 4 squared plus 2 zeros. So then C squared equals 2,000.
2,000.
It gets so quiet in the room
Why
sometimes.
don't we want to take 100?
2,500, yes. So then C is the square root of 2,500. So what squared gives you 25 and then put a 0 on it? 50. Yep. Yep.
So why don't, with these, do we want to not take out the zeros to make it easier?
You just have
It
to
would
put
be
on
easier, but this is the way to do it to keep it all straight.
No controversy.
You're not the first person to say, is there an easier way to do this? No, not
Take the
really.
zeros off everything else. You know, like outside of
Yeah.
algebra, it's just
Yeah.
like check, check, and then you just move on. So that's all.
Yeah.
Okay, I understand.
Notice this was 60 and 80. This is half of the 60 and half of the 80. And the hypotenuse here was 100, and the hypotenuse here is 50. Okay, so this is an example of,
Complementary
pardon,
or proportional?
a special proportion. Yep, a 3 to 4 to 5 right triangle. So if you double them, 6, 8, 10, then if you make it be times 4, this times 4, that times 4, then this hypotenuse will be 5 times 4, which is 20. If I make it be 0.3 and 0.4, then the hypotenuse will be, if it's
0.5.
3.5, yes. Okay, so I can get all complicated. Okay, what if it was 15 and this was 20? That was times 5, so this one is 25. What if it was 1.5 and 2? Then this would be 2.5. Yep. So once you know some of this, and once you know this special ratio, which would probably be on your ACT and SAT, any state test that you'll take once you're at least 8th grade, it'll be on there. So once you know this, then you can apply it. Application is one of your levels. application of this special ratio. There's also another couple of special ratios. One is 5 to 12 to 13. So if I double this to 10 and I double this to 24, the hypotenuse will be 26. Yep. If this one is 130 and this one's 120, what's the short leg? 50, because this was 13 with a 0, 12 with a 0, so this will be 5 with a 0. That makes sense? Okay. Find the area of these. Rectangle, what will you do on that last number 9 for A? What will you do? Area of a rectangle is simply base times height. You'll multiply them. Parallelogram, you have to have the perpendicular height. So which height will you use, the 12 or the 10? Yes, the 10, the vertical one that comes perpendicular to a base. And then trapezoid. Okay, you might need this someday. Because if you're going to figure out, okay, how much square footage of sod do I need on my lawn? I have a trapezoid-shaped lawn. You might say, I don't know, I don't really care. Let me just estimate. But if you needed to know how much area there would be, you could.
You should. Rocks are expensive. You better know.
Yeah.
Just saying.
You don't want to buy too much sod. 8. And this little right angle symbol shows this is perpendicular to the base. So that is the H. Now we've got the formula for rectangle, area of a parallelogram, area of a triangle, but now it wants area of a trapezoid. So it's kind of like area of a rectangle. It's 1/2 times the bases added up times height.
And we can't turn that into 2 triangles and a square like we did the other parallelogram?
You could, if you knew how long this was, you could find the area of this triangle and the area of this triangle, and you could find the area of the rectangle here. You could, if you were given those pieces of information. Question?
Oh, no.
Okay. Okay, so area equals 1/2. Well, what's the top base and bottom base add up to? 28. And then times the height, which is 7. I would take 1/2 times 28. Half of $28 is 14. So now we've got 14 times 7. That's 7 times 2. What's 7 times 7?
49.
49 times 2. Well, 50 times 2 is 100. 49 times 2 would just be 2 less than that. So 98. 98 square whatever. They didn't give it units, so you don't have to. Okay. Questions? Need a break?
Yes.
Go for it. Okay. Whatever amount of time Melissa says.
I have a question. Does your website and your app walk students through all these steps? Like, what kind of steps does it take you through?
Okay. No, that's a good question, because that's a big difference between me and some of the best known ones out there. Pearson or IXL, 3 letters. IXL math is hugely popular. Very expensive, but hugely popular. And if you get it wrong, it'll say, here's the steps, and that's beautiful. Because then you can go, oh yeah, I didn't square it, or whatever. Mine does not. Mine always gives you a second chance. So you can take a break for a minute, throw away trash, hit the bathroom, walk, go get a drink at the water fountain, something, and then we'll start again in like 3 minutes. This is a lot smaller than the East Library room, huh?
Oh, yeah.
But that's okay.
But we have the big room next time.
Oh.
The next,
Oh, there's another,
yeah, and
I mean, there's another room besides this
yeah,
one.
there's the big room.
Okay, okay,
So we'll be in the big, it'll be a bigger class too, but this is perfect for the size.
yeah,
Oh,
yeah.
It was huge.
I'll move it closer.
They need that, that's them do all that.
What is the next best thing you're good at?
The next what?
The next best thing you're good
The next presentation?
at? The next best thing you're good at. If you're like a
Oh.
superstar math person, what is the next best thing you're good at?
I refinish furniture. I can prepare tax returns.
Those are very handy.
Most people are like, ooh. They do that for math too. I'll be getting my hair cut and they'll go, oh, what do you do? And I'd say, I was a math teacher. Ooh. Sorry about that. You didn't have me as a teacher.
Do you upholster furniture or do you finish off?
I know, right?
I'll,
What kind of finish off?
I just reupholster like dining room chairs. It's just a seat. That much I can handle. And you can YouTube video things and find out how to do stuff. But yeah, first summer I was married and I was a teacher, and so I had the summer off. I was so bored. My husband would go off to work and I was like so bored. And so he said, well, if you're bored, you can refinish this table and chairs. Okay, good. You can redo that dresser. Okay. My parents just bought these at an auction sale. Okay. So that's what got me started. And now, like 35 more projects later, I'm doing it.
You're a master.
I like it. It's fun. How about you? What are you good at?
Me?
Yeah.
Oh. It's a great question. I don't know. My life is home stuff. We do a lot of renovations and repairs on homes, so math's very handy for me to touch up on. And my kids, so.
Yeah.
It's kind of my life right now. I don't know if I'm good at it, but.
You won't know it till they're 25 and they go, actually, you were a pretty good parent. Oh, okay, thanks.
Yeah, I hope so.
What is the name of your app called? Is it?
And I did not write those down.
It's on your.
It's on
They are on there? Okay, good. Okay. Yeah, teddy bear math. If you do teddy bear math, and there's various teddy bear things in the Apple Store. If you go teddy bear math, at least it reduces it down. As soon as you put that on, then boom, then it's just mine. And there's 5 of them. But these are like first grade and older. There's teddy bear math addition, teddy bear math adding doubles, teddy bear math sums up to 100, teddy bear math sums up to 50, and then teddy bear math TIBIRI, which just means if you have 25 plus 28. Like I said, I was born before calculators, so I would think 25 plus 3, because these make 50, plus 3, that's 53. So take the problem, break it, remake it. So take it, break it, remake it. Remake it into something easier for the brain. If you have 17 plus 5, this needs 3 to get to 20. So you break that into 3 plus 2, that makes 20. 20 plus 2 is 22. And I know kids, when I'm tutoring, they'll go, And they just want to count on their fingers. No, let's teach you to make your brain do it instead of your fingers do it. And they'll do it underneath the table. But as long as I don't see it, I won't harp on it.
Did you ever use an abacus, since you said that you were going for calculators?
What's that?
Did you ever use the abacus?
I can't hear you.
Did you ever use the abacus since you
No,
were-
no, I'm not that old and I'm not from China. I don't know. I think those are like the weirdest thing. How did people ever think these were good? I think counting on your fingers is a lot better. Then, to get back to my apps, then there's hopscotch, and hopscotch. And then there's 3 of those. And one is simplify fractions. One is adding fractions.
And do those all have a hyphen or a plus sign after them?
Yep, they do.
So
Adding
is it the
fractions.
Apple Store?
Yes, in the Apple Store.
Apple or Android?
Yeah,
They're
that's
on
what I
both.
said.
Yeah.
Okay.
So simplifying, it'll start out on the easy levels like 3/6, 3/9. Well, then I teach kids before I put them on this. That's, you figure out what number can go into both, 3. So you put that on top, you go back to this, and 3 is 3 times 1, 9 is 3 times 3, and then I call it global warming. These 2 fractions melt apart, and any number over itself is 1. So as soon as you have these other 2 numbers, that is your answer. Okay, then it goes to, there's higher levels, there's 10 levels on the Android at least. So it'll go over to like 10/15 or 10/18. Okay, take a 5 out of the top and bottom, take a 2 out of the top and bottom. On the adding fractions, it'll be like 1/4 plus 1/4, which is 2/4, which is, they should know simplifying before they add, so that's 1/2. And then it'll go to higher, there'll be tougher levels like 3/8 plus 3/5. Oh, that's no fun. Okay, that'd be 40th. So that times 5 and that times 3 anyhow. Let's do 3/8 plus 3/8. So that's 6/8. Take a 2 out of the top and bottom, you get 3/4. And with kids, when I help them do this, we work with pizza math and we prove it. And they put all that together and they prove it. I would have loved pizza math when I was younger. I just did it because I was an obedient kid. Okay, I'll learn this. I didn't know and I wouldn't envision it or anything. I just learned it because they said to. I didn't think it was very exciting until I had a 8th and 9th grade teacher, and he made learning fun. He made algebra fun. So that was good. On the multiplying fractions, that would be my 3rd hopscotch one. That'll be like 3/4, times 4/9. And then you go, okay, 4 goes in here once, 4 goes in there once, 3 goes in there once, 3 goes in there 3 times. So then 1 times 1 over 1 times 3, done. Okay, I've done a bazillion of these, so that's, I know it's fast, but I want students to get fast. I want them to be accurate, but be fast if possible. Okay, 3/25 times 5/9. 5 goes in here once, 5 goes in there 5 times, 3 goes in there once, 3 goes in there 3 times. 1 times 1 over 5 times 3, 15. The toughest levels on Android will be like 85 over 300 times 60 over 51. Okay, 17 goes in there 3 times, 17 goes in there 5 times, 60 goes in here 5 times, 5 cancels 5, you get 1/3. One of my tutoring students, she's a happy working 7th grader. And she goes, let me try the hardest one. And then she goes, let's go back to level 4. Okay. I think that's wise. Okay. But if you're thinking, well, I'm in high school, I don't need to do multiplying fractions. Actually, you can just make your brain more agile, and that's good. When you're in any kind of sport, you're going to want to be agile to be able to pivot and do things, kick, turn, whatever you need to do. Same within math. You want your brain to be agile. Okay. Number 10, if you want to look over 10, 11, 12, 13, 14, are there any you want to just skip over for now? Or is it okay to just keep going? Is that fine? Keep going? How many think, oh, okay, it's probably good for me? Okay. Are you already done with them? You just did one? Okay. Okay, that's fine. If you are done, I can give you something else to work on. I have more stuff. Okay, truly. Find the area of these combined shapes. Okay. Okay, that's going to be a rectangle, and that's going to be a half of a circle. So if this is 6 and 10, what's the radius? 3. Okay, so then this area will be base times height. So area equals the 6 times 10. So area will be 60. Then this part is area equals pi times what? R squared. Yep. Area equals 3.14 times, who cares, 9, 3 squared, which is 9. Area equals 6, 2, 28. Okay. Do we need all of that? That's the area of the whole circle. Do we have a whole circle? No. So we actually need half of this. Like this will be 60. And this is only a half of a circle, so half of 28.26 would be 14.13.
And do you always multiply out the pi? Because I've seen some teachers do it and then others didn't. And it would be like 3 pi or 4 pi, and it's just the pi.
I can't hear
They left
y'all.
the symbol instead of put 3, 1. They would leave the symbol for pi
Oh.
instead of multiplying it out.
Yeah, and I think that's very valid to just leave it in terms of pi. Yes, because if you say use 3.14, everyone will punch it through a calculator. If you leave it in terms of pi, if you did, then this would be 9 pi, and then you would need half of that, so you would need 4.5 pi. The area would then, the area of that combined shape would be 60 plus 4.5 pi. It's kind of clunky for our brains to think, envision how much is that? Well, it ends up being these two together, 74.13. Okay. And if your parents are going, I really didn't like algebra when I was going through it, and I still don't, well, sorry. Next one. It shows right angles here, and it shows this is 8 and 8. So what kind of shape is that? Square, yep. And then, I don't think somebody's battery. It isn't mine. Oh, would that be one of these batteries?
No, it's not.
Okay. All right. So this is 6. So the area of the square would be base times height. So 8 times 8, which is, yes, 64. And then we need 1/2 base times height. If you turn this, you've got a triangle where this is 6 and this is 8. So area equals 1/2 base times height. Area equals 1/2 times 8 times 6. 1/2 is 8 is 4, and 4 times 6 is 24. So I'm going to make this 6 be smaller so that my area, so what's the total area of the combined shape?
88.
88, yes. Okay. Okay, next one. You have a triangle. This is 8, 8, and 8, and the height, it says, is 6.93. And then you have a circle. Diameter is 18. Do we need the diameter? We need the diameter only to help us know what is the radius. So then the radius must be 9, okay, because you're figuring this out. Okay, so then you're going to need the formula for area of a triangle, which is 1/2 base times height. Okay, area equals 1/2 times the base times the height. Man. .93. Okay, 1/2 of 8 is 4, so I need 4 times 6.93. Area equals 27.72. Okay. Then how about the area of a triangle? What's that formula? I mean, the area of the circle? Pi r squared, yep. So area will be equal to, let's leave it in terms of pi, times 9 squared, which is 81. 81 pi. So it's this plus this. 81 times 3 would be about like 240, so around there. It's drawn way out of proportion, obviously, because if this is supposed to be 200 and this area is 27, whoops. I did not make them be in proportion. Okay, find the volume of each sphere. Okay, another formula. Volume equals for sphere, anybody know that?
Oh.
Pi r cubed, isn't it?
Pi r cubed. There's a 3 here and a 3 here. 4/3 pi r cubed. How someone ever figured that out? I don't know. But now they make everyone learn it. For better or for worse. Okay, so on the first one, the only thing you need is the radius. So the radius gets cubed. What's 3 times 3 times 3? 27. And then 3 goes in here once, and 3 goes in there 9. 9 times 4, 36 pi. Yep.
Pi is 20/17. And the fraction, what is it? What's the fraction form of pi?
Did I do something wrong?
No, I just want, what is the fraction form of pi? Not the
Oh,
decimal form.
22
22.
over 7.
Right.
Because 7 divided into 22, 0, 0. 7 goes in there 3 times. I use it up 21, subtract to get 1. 7 goes in there once. Subtract 7, you get 3. 7 goes in there 4 times. 3.14. Only this goes on and on and on. The sevenths do.
No, those weird kids who know like 100 digits after pi, and you're like, why? Why? For what?
Turn into a 3-year-old. Why? Why? Okay, find the volume when the diameter is 8. So the volume is 4/3 pi 8 cubed. Oh my, okay. What is 8 cubed? Anybody know?
So 8 times 8 is 64. 64 times 8.
I know it's big.
You're getting there. Okay. 8 times 8 is 64, and then you need to take that times another 8. So 60 times 8, 8 times 8.
Oh, so that's 480 plus, so 484.
$512. And 5 plus 1 plus 2 is 8. 3 can't go into 8, so we're done. Except you can multiply numerator times numerator. 4 times 5 is 20. 4 times 12 is 48. 48. 3, and then pi. Okay, can you look at that problem and go, yeah, I think that's reasonable? If you can, that's good. Okay. All right, last one, radius is 20.5 feet. Let's not do that one. That would be a prime time for a calculator, because taking 20.5 times 20.5 times 20.5, that's just recipe for way too much work. Okay. I mean, given our time constraint. Okay, find the volume of these cylinders. Give me an example of real life cylinder.
Like a orange juice can?
Yeah, like an orange juice can, yes. Okay, so the base of it is a circle. So the base is on top and bottom, they're alike. And then if this was like a tomato soup can and you pulled the label off and you pulled it out, what would it look like? A rectangle, yep. So the volume will be base times, well, no it won't. The volume for a cylinder is pi r squared h. It has to do with the circle, and then if you considered little paper discs that you put in there that were always pi r squared area, and you did it for that entire height, that would be the volume that would fill it up. Volume means like how much it'll fill up. Okay, so on this one, diameter is 10, the height is 5. Do we need 10? We need 5, because we need the radius squared times the height, which is 5. Oh, not bad. What's 5 times 5? And then 25 times 5, which is like 5 quarters, that would be worth 125 times pi. So why do we put the pi last? It's just a rule. That's just the way they do it. They put the variables second. This isn't exactly a variable because it's always 3.14, but they put that second. They put the coefficient first. Okay. Next one, diameter is 12 and the height is 20. Do we need diameter?
No, we just need 20.
Okay, and so r squared h volume equals pi 6, which we have to square times the height of 20. 6 squared is, okay, 36 times 20 times pi. Okay, volume is, let's just look at this as a 2. What's 2 times 30?
Oh, 60?
60, and 2 times 6, which is 12. 60 and 12 makes 72.
So 720.
Yep, so then we put the 0 on 720. Okay, and learning how to do that is on the website. I'll show you. Okay. The last one of that type, radius and height, so volume equals pi times the radius, which is 12, times the height, which is 10. What's 12 squared? 144. Now when we take 144 times 10, you'll get
1,000.
okay, you're going to get 144 with a 0, and then you say pi. Yep. While we're at this, page 4 does not have much on it. So you're nearing the end. Yay! Okay, I want you to list, whoops. Okay, use this space. Give yourself about 2 inches for number 16. But then I want you to put 1 squared, 2 squared, 3, let's just do 1, 2, 3, 4, all the way through 20 if you can. I probably should start it up higher. Okay, if I call this number n, and then we're going to make the column where it's n squared, that number squared. It starts out nice. What's 1 squared? 1. What's 2 squared?
2.
What's 3 squared? 9. 4 squared? 16. 5 squared? 25. 6 squared? 36. 7 squared? Okay. 8 squared?
64.
Yep. 9 squared? 10 squared? Okay, now I'm going to stop and I'm going to show you something and you're going to go, wow. No, just kidding. If you're at this square and you want to get to the next one, take the square and add these 2 numbers. See how they're 3 plus 1 makes 4. So if I'm here and I want to get to the next square, add 2 and 3, that's 5, plus 4, I get 9. 3 and 4 is 7, plus 9, I get this.
Great, Tom.
Wait.
You take this one and the next number. 9 plus this is 25.
Who taught you this?
Pardon?
How'd you learn that?
I used to ride the bus for an hour in the morning and an hour in the afternoon, and I got bored. And I read a lot of books and I listened to a lot of radio, but I rode the bus a lot. And I tried to figure out exactly that. Why is this true? And there is a reason for it. Now, it comes in handy because if you want to know the square of 11, you take 100. What do 10 and 11 add up to? 21. So you add them onto 100 and you get 121. What's 11 and 12 add up to? 23. So add on 20 and 3 and you get 144.
That's wild.
What's 12 plus 13? 25. So add on 20 and 5. And this needs to go across here.
How'd you?
Okay. Just trust me on this one. It is 196. The way to remember it is if these 2 just trade places. And then 15 squared. I'll show you more fun stuff.
Fun or tricky?
Okay. Then these 2 add up to 31. So add on 30 and 1. 30 and 1, and you'll get 256. Then add on 33. Add on 30 and 3. Yes, 289. And then just trust me, 324, 361, and then 20 squared, which is? 400. Now, knowing what you know, what is 21 squared? Well, you add up these.
441.
441. See how smart you are? Woo! Okay. What is 30 squared?
So that's just about
900. So what's 31 squared?
so that's
Add up these to that. 961. You're so smart. Okay. Okay, there's more good stuff. Trivia, but that's okay. Make another column. This one won't be so long. 5 squared, 15 squared, 25 squared, 35 squared. Yes, they all end in 5. What is 85 squared? Anybody know? You will in a minute. Okay.
Oh.
Okay.
8, 5, 2, 8, 12.
Okay.
7 doesn't 2,
5 squared is 25. And then all of these are going to end with 25. Okay, now, just works out that you take this tens number times the very next one. 1 times 2 is 2, 25.
Wait, say.
Take this one times the next one.
My brain hurts.
Take this times this one, and you get 6, 25. Isn't that just the oddest thing around? And why don't they teach this? Because it's kind of fun in its own mathy kind of way. Say it again.
2 times 1 is 2,
Okay.
and then 25.
1 times 2, and then you say 25. 2 times 3, which is 6, 25. Now I'm at this one, so I'm going to take this times the next number. So that'd be 12, 25.
I'm surprised none of us are.
And then what's 45 squared? This times this,
Don't be like 20. Forever and ever.
20, 25. Now take 5 times 6 and say 25. Yeah, 30, 25. What's 65 squared? Yes, 42, 25. What's 75 squared? You got it, 56, 25. Now remember, I asked what's 85 squared? And it is, you take this times this.
7,225.
Yep. And 95 squared, well, that would be a 10. That's next. So 9 times 10?
90, 25.
Yeah, 90, 25. Okay. As far as I'm concerned, in middle school, there should be at least one semester, if not a whole year, of just learning all this mental gymnastics kind of stuff to help you. Now, we can apply this. So if 25 squared is 625, what's 2.5 squared? Well, it's still going to be 625, but where does my decimal go? 2.5, 2.5, so my answer has to have
2 decimal places.
2 decimal places. So what's 0.25 squared? Well, it's still going to have 625, but it has to have 4 places. So 1, 2, 3, 4, I have to add a 0. Okay, let's pick on this one. So what's 7.5 squared?
So we have 25.
5, 6, 2, 5, 1, 2, so 2 places. So what's 0.75 squared? Yes, 0.5625. What is 750 squared?
What?
Walking in tonight, you probably didn't know what 750 squared was, but now that you know what 75 squared is, what would be that one? 56, 25, and then how many zeros?
2 zeros.
Those.
Yep, those. Okay. Yep, that's a comma. Okay, done with that trivia? Okay, it's just good to know a lot more so you don't have to always reach for a calculator. And when you're in chemistry and physics, oh my, they use a lot of decimals and a lot of squaring and square roots and stuff like that. So it's just good to be able to know how to do that. So we're towards the bottom. Number 13, name each triangle as acute, right, or obtuse. And then do it again as equilateral, isosceles, or scalene. Okay, number 13. So, because you can name triangles according to their angles, and you can name them according to their sides. Okay. Acute angles are how big? They're less than 90 degrees. Right angles are just right. They are exactly 90 degrees. And then obtuse are the ones that are bigger than 90. Okay. You can kind of remember acute are the little ones because acute puppy is little, so it's littler than 90. Scalene would mean no sides are alike. Isosceles, two sides are alike. At least two sides are congruent. The symbol for congruent is an equal sign and then a squiggle. And then equilateral is three sides are congruent. Okay, like yield signs. Oh, man. Yield signs are going to be equilateral triangles that are, to me, upside down. Okay, that's where you see them in life. Isosceles, you can remember two sides are alike. See how it's SOS? These two are alike. Same thing happens here. These two are alike, but not that one. Okay, technically, it just means at least two sides are alike. So is an equilateral and isosceles? Yeah, technically. Big deal. Will that rock your life? Not too much. Okay. 13A. Name according to the angles. Obtuse and no sides alike, so scalene. B.
Equilateral and acute.
It doesn't show equilateral. I mean, if it's going to be equilateral, they should have designated this is congruent to that, is congruent to that. So we have to just assume it's still scalene, but it's acute. Okay, and the last one has what kind of angle? Right angle, therefore it's a right triangle. It shows this is congruent to that, so it's isosceles, yep. So it's a right isosceles triangle. Okay, the next one, the measure, this is amazing, the measure of the exterior angles of a regular polygon is 360 degrees. Always, always, always. Wow. So then find the measure of each one. Well, a regular pentagon, penta means it has, how many? 5 sides. So if you have 360 and you divide it by 5, here's what my brain does. I have 360 and I need to divide by 5. I'm going to make that be 350 plus 10, because this does not hurt my brain. And dividing into here and dividing into here. So 5 goes into 35, 7 times with a 0, 7, 5 goes into there.
Plus 2.
Yeah. So will this rock your world to know that a pentagon has 72 degrees on each side, on each exterior angle? No, it won't necessarily rock your world, but you will have to be accountable for it, probably on an ACT test or building up your math skills, trigonometry, things like that. Regular hexagon. Hexagon has an X. It has how many sides? 6. So 360 degrees divided between 6 angles. 36 divided by 6. Okay. So each one of these exterior angles is 60. Yep. There's all kinds of cool stuff about regular hexagons and apothems and all kinds of stuff. But you just have to wait until you get there. Just kidding. Regular octagon. Octagon has 8 sides, so 360 divided by 8. I'd make that be 320 plus 40. 8 goes into 320 4 times, and 8 goes into 40 5 times, so 45 degrees.
Whoa.
Does that make sense? When you see it?
All polygons equal 360 degrees?
The total of the exterior angles is 360 degrees. Kind of amazing. Okay. Okay. So what kind of shape are these? Cylinders, yes. What kind of shape is this? Cube. What kind of shape is this?
Square.
A square on the sides, but these are rectangles. So this is a rectangular prism. This, you name it according to its base. So if you laid it down this way, you could say a square prism. If you lay it up this way, the bottom, the base is a rectangle, so rectangular prism.
Hecto.
No.
Gone.
Pentagonal prism. Okay. This is back to
Cube.
cube. This is
Rectangle. Prism.
a square prism, or you can call it a rectangular prism because a square is a rectangle anyway, technically. Okay. What kind is this?
Triangular.
Triangular prism, which is, whoop, we're not there yet. Okay. And this one is also a triangular prism. Okay. This is a pyramid. How is that different than this one?
Because it has a bottom.
They both have a bottom, but they don't have the same top. So you're analyzing, what is the difference? How do I say that in words? Okay, they all of these sides go up to a point. The question is, how many faces, edges, and vertices do these have? Faces means how many flat areas. So if you were holding this, it has a base, and then it has some sides. So grand total faces would be 4. Edges, there's how many edges around the bottom, and then there's how many going up? 3. So a total of how many edges? 6 edges. And then the last one, how many vertices? That's like point, corner point. Here, and then the 4. Okay, rectangular prism. How many faces does a rectangular prism have? 6. And then how many edges? So how many around the top? 4 around the top and 4 around the bottom. And then you connect the top and bottom, so there's a grand total of 12. It does make you think, huh? And then how many vertices? How many on top? How many on bottom? Done. 8. 8. And then pentagonal prism. Okay. How many faces? There's top and bottom plus how many? 7. Yes. And then how many edges? Think of how many on the top, how many on the bottom, and then all the connecting. 15, yes. And then vertices. How many vertices does it have? How many on top? How many on the bottom? Done. 10. Okay, no formulas. Just analyze and come up with the answers. Oh, how many diagonals from just one vertex may be drawn for each of these? Okay. And okay, just give me the, cut it short. Sign if you need me to. I know, and nobody's like yawning or fake yawning yet, so that's good. How many diagonals do we have? Well, there's this one, and there's this one, okay? But it says from just one vertex. So if I can only do it from just one vertex, then there's only 1. And then the next one is if it's a hexagon. And I'm just going to make it the classic hexagon shape. If I start here, I can't connect there because that's a side. So I can do this one, I can do this one, I can do this one. I can't do that because it's a side. So how many are there? Okay, there's 6 sides and 3 diagonals. Okay. This one had 4 sides, 1 diagonal. And then decagon. Oh. You don't want to see me try to draw a decagon. Okay, so let's look at the pattern. I could do an octagon. It just isn't on your page. Ooh. Okay, so there's 8 sides. From here, I can't count this because that's a side. I can count this one, this one, this one, this one, this one. I can't count that. So how many diagonals were there? Should I do it again? More carefully?
No, I saw it. I'm just trying to come up with a formula in my head.
You're already trying to come up with a formula. Whew, I like that. Okay, so from here, can't count that. I can count to this vertex, that vertex, that vertex, that one. I can't count that one because that's a side. So how many diagonals from one vertex? 5. Okay.
I'm catching on that it's -3, that's all I'm doing.
Okay. Then what do you notice about the number of sides and the number of diagonals? 4 and 1, 6 and 3, 8 and 5. The number of diagonals is always how much less? 3 less. So now I'll go ahead and do that last one. If you have a decagon, how many diagonals can you draw from one vertex?
7.
You're so smart. Okay, and it's good if you can figure it out. Okay. Do you need another break again?
Yes.
Yes, a vote. Okay, go for it, and then I'll hand out, or we'll go to your next handout in your folder, and I'll try to have you have fun with that one. I'll try. Okay. So if you need to take a break, go for it. And actually, I'll come around and show you.
Where were you commuting from that you were on the bus for an hour and a half?
What's that?
Where were you commuting from that you were on the bus for an hour and a half?
Oh, I grew up in Minnesota in a little tiny town, and the bus would come out from 12 miles. Well, it'd come out 11 of the miles, and no, it'd come out all 12, and then it would start a whole route. We were the first ones, and then it would do the whole route and then drive on back in. And then in the afternoon, it would come 1 mile away from us and do the whole route, and then drop us off last. That was not fair, but it was what it was. Okay, but oh well. It was good. You're not going to go walk out and do something?
No.
Okay, all right, cool. Could I have you spin around to be at that table, and you can spin around to be at that table, and then could I have you pull this out and you come and spin this chair and be over here?
Turn right back
Okay.
around. I need help. Help!
Okay. So it looks like you're all back from your break. No, just kidding. Okay, you have 2 parallel lines. cut by this transversal and that transversal, and then you have a ray that's coming here and you make a triangle at the top. Okay, so
I'm assuming that's some sort of combined shape.
Then-
They're actually on the paper?
Oh, yeah.
Oh, okay.
okay, so then I give you just enough information, you should be able to find all of these angles, the measures of all of the angles. It's easier if you go up here, or see how this says angle 6 is 135 degrees? Then go up here and put 135. And then vertical to it,
Angle 6 is 135 degrees.
yes. Okay, then angle 8 is vertical angle with it. So it is also 135 degrees. And then, if you start climbing up that transversal, you go to this collection of angles, which 135 is obtuse, correct?
Yes.
So start going up here. There's angles 1, 2, 3, 4. Which ones are obtuse? Analyze. 2 and 4.
Oh,
So 2 and 4 are also 135. So then, once we know those, then we can find the smaller angles. Okay, angles 1 and 2 make 180, correct? Angles 1 and 2 make 180.
I know, but why does it say L3 is 42?
You're on C, I'm on A.
So turn the page around.
There we go. Oh, I gave you the answer key. Oh man, that was nice of me. I'll get you a different, oh, you can just have this one. I'll get another one for me. Does anybody else have all the answers filled in? She's the only one I accidentally gave the answer key to. Okay.
Good. I didn't understand it.
Okay, 135. Okay, so angles 1 and 2 are 180 together, right? So if I take 180 and I take away 135, 100 minus 100, gone. 80 minus 35. What's 80 minus 30?
50.
And then take away 5.
45.
45. So angle 1 is 45. What other one is 45? Yes. And then slide down that transversal and you get to angles 5, 6, 7, and 8. How big are 5 and 7?
4 times 5.
45. Yep. Okay, now it's going to start getting messy, so you might want to put them outside. Okay, at least we've gone that far. Then it says angle 12 is 136. So I would label it. What else is 136 then? Okay, if angle 12 is 136, then the vertical angle would be angle 10. So angle 10 is 136.
I can't see.
So then 11 and 9 are 44.
Okay, so 11 and 12 make 180. 180 minus 136 gives you 44.
So then this line, then, so this one is also, so 20 would be 44 too?
Okay, hold on. Not necessarily. So that little tiny triangle there,
See, I knew it.
that little tiny triangle has a 45 and a 44. So the grand total for the angles of a triangle is always 180. So 45 and 44 is,
Where are you getting 45?
80,
this one's 45 and 44.
40.
So those two together would be 89.
Yep.
So then It isn't a labeled angle yet. So then the bottom angle of that triangle, 180 minus 89. What's 180 minus 80? 100. Now take away 9. 91. So this one is 91, but it doesn't ask you for that. It asks you for the one on the other side of it, which is angle 19. Okay, so if you have the,
Oh, so you guys are right.
if this one's 91 and I really want this one, what's 180 minus 90? 90. Now take away 1. 81. 89, yes. So angle 19 is 89. Whew. Okay. Then we know 112 for number 12 is 136. Slide up that transversal. 12 sits on top of the parallel line and on the left. So that would be like number 16, angle 16. So angle 16 is 136. What is vertical with angle 16? 14. So angle 14 is also 136. And then angle 13 and 16 make 180. 180 minus 100 is 80. And then 80 minus 36. 80 minus 30. And then minus 6. 50 minus 6. 44. Which it's supposed to be because it should match ones down below.
What number is 44? 18?
15.
Oh, yeah, I got that. 'Cause they
Okay, good.
wouldn't, because they matched 7 and 11? Or
Yeah.
9 and 11?
Yes. Yeah. You could find it a couple ways, but yeah.
It was 54,
Okay.
right?
44. 44.
Then it tells you angles. Down here it tells you angle 17 is 82. Angle 17 is way up here. If this is 72, and that and this unnamed angle make 180.
What makes 180?
An unnamed angle. Hold on, I'll show them for a minute. In this triangle, 17 and this angle make 180. If 17 is 82, 180 minus 82, 180 minus 80,
80. Wait.
It's 98, right?
100, and then minus 2 is 98. So that one is 98 right there. This one that I don't even ask about, 98, but you need it. Okay, now in that triangle, this is analyzing and applying. Okay, now you have two of the triangle angles known, a 44 and a 98. Reaching overload? Just a little. Okay, we have to add 44 to 98. Take that 44, break off a 2. Give it to the 98, you got 100. 100 plus 42 is? 142. Now the angle at the top is 180 minus 142. So 100 minus 100 gone. 80 minus 42. 80 minus 40.
38.
And that 40 and then minus 2 is 38. Yes. So exciting, isn't it? Okay.
My head's gonna hurt tomorrow.
Okay.
My brain.
Make sure I'm
So that 142. Yes. Okay. Okay. So which angle did we just find? 18. 18 is 32 degrees. Isn't that what you just said? 142, yeah, 38 degrees. 38, yes, yes. 18 is 38. Now 18 and 20, angles 18 and 20 make 180. So then 180 minus
20.
What was 18? 38. Okay, 180 minus 30, 150, and then 150 minus the 8.
152.
142, and it is supposed to be obtuse. Okay. So angle 20 is, okay, I think we did them all. Okay. Here's an answer key, and then I'll give somebody an answer key. I have more answer keys.
He said the answer key is where?
I
I didn't even see them on here.
have more. I'm not even charging for these. I'm not even charging for the answer key. Okay, sure. Here you go. Sure. Okay. Oh, it's almost 8. That one was a hard one. Because you have to take your knowledge of supplementary angles, complementary angles, angles of a triangle together, and then you want the other angle. It's good. It's good from my standpoint. We could go through another one, but I think you're done, and it's approaching 8 o'clock, and that's just fine. Okay. Why don't you pack up, and then I'll just have you do something gentle on the brain. Okay. This one's nice. Okay, they're always finding the perimeter. This one's a square. So if this side is 3x, then that's 3x, 3x, 3x. So what's the whole perimeter? 12x. Doable. And it's done. Okay, this has a little congruent sign and congruent side. 3x plus 2 and another 3x plus 2 would be a total of?
6x plus 4.
Yeah, 6x plus 4. And then there's a 5x minus 7. Okay, you don't have to do that one at 8 o'clock at night. Okay, this one's square. X plus 2.
4x plus 8.
Yes, okay. So you can do those. Now, do them at your own speed, and the answers are all on the back. That's the wonderful part. And then here. Oh, you don't want any? Okay. I just didn't want to leave anyone out. There you go.
Here, Melissa, here's some
This obnoxious Barbie pink or green.
12.
Oh, come on. Challenge the brain a little more than that. Hey, you. Okay, so a 1x and a 2x would be,
24.
so like go around and add the x's. 1x and 2x would be 3x, plus this 3x would be 6x, but then you have a minus 3.
3x plus 15.
What's the next one? Okay, so if that's x, that's x. That's 2x plus 3, that's 2x plus 3. So 2x plus 2x is 2x. So a total of 6x plus, this had a plus 3 and a plus 3, so it'd be
2, 4, 6, 8, 10, 12, 16x plus.
very good visual skills.
Yay, you won. Good job.
Here, I'm going to give you this one. It has how many sides?
Okay, I can do this. You can go to the other card. See the adventure.
X. 6.
Yes. So you have 6 sides, and they're all 3x plus 5. So what's 6 times 3x?
6 times 3 is 10, 20, 30, 40, 18.
18x plus 6 times 5, which is 30. So 18x plus 30. Okay, you're done. Everyone's done. Okay, do you want to hand them in? I can show you a little bit on the website. You sign up for it, and then that you have to put in an email. You give yourself a username and yourself a password. Choose a password you'll remember, like your address, your dog's name, or something like that.
I was told if you make a statement, then it's like easy for you to remember your password.
Yeah.
And so like I have it like with all sorts of symbols and like work, and I'm like, woo!
Well-
A creative, strong password that I came up with by myself, not with a generator. Like, for real.
Okay, I don't think anyone's chosen the password I love math. You can have it if you want. Just saying, okay. Maybe somebody's taken it. It's not. Mine's super simple.
With like the ash symbol and what else?
Okay.
Did you put in there?
So-
Maybe like a dollar sign. Yeah, I got it.
Oh, don't tell us your tricks. No, just kidding. So there's always these 4 that once you signed in, there's the 4. Math Foundations really is the foundation. It's got adding, subtracting, multiplying, value of coins, change back from a dollar bill, $5 bill, fractions, decimals, percents, squares, square roots, all kinds of stuff, absolute value. It's huge. It's got probably 8,000 problems just in that. The next biggest is algebra, and that probably has 3,000 problems. And then between these is another 1,000. So there's like 12,000 problems, over 12,000 problems. Sometimes the hardest part was, like, okay, how do I make wrong answers? Because I had to come up with 12,000 right answers and about almost 50,000 wrong answers, or 35,000 wrong answers.
A consecutive integer.
Okay,
Why?
that shows you the wide variety of topics. When you touch one, it shows you how many sets of problems. There's always 25 problems in them, in every set, and you can get an idea. There's always an explanation, examples, and directions. Go back to monumental math, and then we'll go to algebra. Lots of titles, but not as much as Math Foundations. Okay, one-step equations. Oh, that'd be nice. One-step equations. So times 25, there's 125 problems just to practice that topic. It tells you I think it's
And
important.
you did all this by yourself?
What?
You did all this by yourself?
Yeah. My son gave me the way to type in the title, type in the explanation, and all of the problems and all of the answers. Yeah. So I did that during the 2014 Winter Olympics. I was doing my work as I was watching all the ski jumping and stuff. Okay. We'll do this one. Set 1. There's me giving an explanation. The videos are usually somewhere 2 to 4 minutes long.
Okay.
They are exactly the examples. I go through the examples.
Did you have videos the last time you presented? I did the one with the elementary. And you had videos on there?
Yeah, I have about 300 videos out of the 500 titles. Yeah.
God bless you.
One of the person that did the videotaping is a former student of mine. So look out. If you know me, I might hook you into doing something for me. But I paid her, hey. Okay, here's a way to do this so that you increase your mental math abilities. Okay, what plus 2 makes 26?
28. Oh, you said what plus 4?
What plus 2? 24. So this has to be 24. 3 times what will make it be 24?
Oh, God.
3 times 8.
24 minus.
Nope, divided by the 3. Okay, doing the same thing. What plus 4? Somebody already said the answer. What plus 4 makes 19? 15. So this has to be 15. 3 times what will make it be 15? That's right. Okay, you are so smart.
Don't y'all talk about me.
Okay, analyze and make your decision.
I'm remedial.
What plus 4 makes 28?
24.
So 3 times what will make that be 24? 3 times 8. Good.
You know, you make this look so easy, and then if I went home.
I want it to be
Okay.
easy. Okay, I want it to be very attainable.
Is the answer 4?
The answer is 4, because 16 plus 5, so this has to be 16, therefore x is 4. Okay, like that. Anyhow, that gets you.
Show us what happens when you get it wrong.
Oh,
we
good
got the
idea.
wrong answer.
Okay, we'll say it's 10. And that'll give me the caution light is what I call it, yellow, like, So then if you get it wrong, say I do it again, if you get it wrong, it makes it a red, but it just goes on. Life goes on. We're going to make a lot of mistakes when we're learning math, so life goes on. So now what plus 2 makes 17?
The answer's
15, so then 5x is 15, so x is 3, yes. Oops. So if I do the wrong answer, and then I do the right answer, it pretends it never happened, so it just gave me credit for it.
And no sound effects, because I don't want the. You know, like,
No sound effects, no. Just the one that'll be in your head going, oh man, I should have known that. Okay, but you've been a wonderful group tonight. Thank you for being very good listeners and all that good stuff, and you're not giving me that fake yawning look, so that's good. I applaud you, good.